it. So let us again go back to the problem wherein we have to compare our linear interpolation estimate versus the exact solution using integral calculus and quadratic equation function representing the coefficient of thermal expansion. This is exact answer. So let us compare by calculating the error. What is the error? Okay. So the error is 0.0137 minus 0.01204 divide by 0.0137 times 100. We can multiply it by 100. Okay. Look, I put the parentheses. If not, this will become an error. So I already know it. I already know it. I am new to this calculator. Different model calculator I used in my own board exam. So I am new with this type of calculator model. So let us 12% error. And therefore, since we have 12% error, this is not yet acceptable. Okay? 12% error. Statistically, acceptable error is 5% and below and less. 5% and less. So, in my case, I will not stop with this. I will use another method in order to come up with the final answer with errors about 3%. That is my personal opinion. I always use 3% rather than 5%. I use 97% rather than 95%. Okay? So, this one is what? 88%. Very low. For me, it's very low. This is not acceptable. Scientific community will not accept this because worldwide, 95% is the acceptable likelihood. Okay, so this error is not yet good, particularly we are engineering. Okay, okay, so but still, that is a good practice. There are many things that we are able to learn how to use the calculator. There are details that we learn. Details. How to use interpolation, linear interpolation. Since linear interpolation did not give us the acceptable accuracy, I will use quadratic interpolation. Okay? But I will not show it to you today because that is not my subject. That is mathematics subject. Okay? There is a quadratic interpolation. Okay? So I just give you the linear interpolation, which is also good. It's also good, but you have to check it with the we have to verify it with the answer. No? So that is because if you use T here, okay, our value, which is 5.18, we use 5.18 as our value of what? Thermal coefficient. No? So, for example, let us use this equation. Let us use this equation. Okay, I will show you. Let us use this equation to be able to determine the actual value of thermal coefficient. So let us use the calculator. Use your calculator. Okay, using your calculator, we have what? Negative. Negative 1.2278 times 10 to the negative 5. Negative 5. Okay. Times t, which is what? Which is what? Negative what? 108 squared plus 6.1946 times 10 raised to the negative 3 times negative 108. Okay, plus 6.015. What is the answer? 4. So the answer is 4 rather than what? Our answer is what? 5.18. The answer is 4.23. Okay. For the alpha, for the thermal expansion. Okay. So that's why we have that kind of answer. So if we use 4.23, okay. If we use 4.23, okay, let us go to our calculator. Let us use 4.23 here as our coefficient of thermal expansion. So 4.23. Our answer would be how much? Our basis is from 6.015. Okay, so it is different, no? It's different analysis because we have what here? We add 6.015 here in this part. Okay, here. So our basis is not starting from 0. What is our table? Our table is a table. Okay. Tap into this one. So we have what table between 4.72 and 5.43. Okay, that is the value. It is between the two. So between 4.72 and so there is a discrepancy. I will show you in our table. Okay, the tabulated value, which is given by this example y. Okay, so 1.53 here in this table. Here. This table, as you can see, this table okay, 4.72 and 5.43. Okay. But, okay. There is something wrong with this table because, okay, because our computation, okay, here, using the exact equation, 4.23. And 4.23 is not between 4.72 and 5.43. Okay? Okay? The same question by, who is the guy who asked that question? Montes. Oh. The question by Montes a while ago. The same logic I am going to use to ask question to this example. So in this example, there is also some error in calculator because our answer is 4.23, which is not in between. Okay. So 4.23 is not between the tabulated values here. Okay. 4.23 is not in between 4.72 and 5.43. Right? So there is something wrong with the calculation of this. Okay. Imagine it is not only calculated in this manner, it is also given using the exact formula. Okay? Using this exact formula. Take note. Okay? So therefore, there's something wrong here. There's something wrong in computing the table using this equation. There's something wrong. Okay? That's why our answer is, so doing these things, you can what? You can be aware of so many other related details. Okay? That's why it's very interesting to do practice. Okay? You will know which tabulated values are wrong. Okay? So that's why you have to practice. Practice and practice and practice. Okay? We don't need just to accept the values. Okay? This value. So we can actually do the integration here, which I will not do because it will waste our time. It is very simple to integrate t squared. What is the integral of t squared? dt. T squared dt. T cube over 3. That is the integral. What is the integral of t? dt. T squared over 2. That is simple, but you have to do it on your own. I am not a calculus teacher right now. Okay? So you can do it. You can also practice that and compare again the result. So many things you can do. Okay? So because of that, you can even check. You can go back to our practice. I'm sure you take note our result and screenshot our result. Okay? So you can do it. You will have more practice. Okay? You can check here. I don't know why I have difficulty connecting to the internet. I don't know. I don't know why the internet is okay. I don't have the monitor. I don't have the monitor cell phone because it is low band. So it is low band. Okay, I cannot monitor. I cannot monitor if I have sound. If I am being what disconnected or something. So I cannot check. So please remind me if I don't have sound or I am disconnected. Okay, let's go to the next. Okay. Okay, these are steps. Okay, these are steps that we already know of, and we will not do it again. You have to rewatch the lecture. Okay. I have difficulty connecting today. Very difficult to connect. Okay, so this video is the video number 1, and to remind you, we are actually doing the nonlinear equation right now. Chapter 3, okay? And we are already through with the nonlinear equation. There are three methods that we use to solve nonlinear equation. What are those? Bisection method, Newton-Raphson, and what else? What is the other one? The secant method. So there are 3 methods to solve nonlinear equation. And also we are through with differentiation. We are also through with differentiation. Differentiation is chapter 2. Nonlinear equations is chapter 3. We are already through. We are done with this. Simultaneous linear equation, this is chapter 4, and that is our next chapter. Maybe we'll start next week. Simultaneous linear equation. Okay, curve fitting, we have interpolation. Okay, that is my coverage. It is under my coverage, the interpolation. So please take note of that. So that during curve fitting, I will have another example or 2. We will not go to it in such detail. We already detailed it with computation and with example a while ago. Interpolation. Integration after the simultaneous equation. Okay, so we have so many things to lecture. Okay, right now we are through with differentiation and nonlinear equation. There are 2 chapters. So let us look for another practice. So we still have 20 minutes. We still have 20 minutes to practice today. If you have any question, you have to ask question. You can also use our textbook PDF in order for you to practice. You don't need to wait for me to say use the textbook to practice. We have this textbook, 7th edition by Chapra and Canale. Chapra and Canale, it is good for us because they are also civil engineering. Civil engineering is computing and engineering professor, civil engineering professor. So we can relate to their problems because they have the same discipline, civil engineering. Okay, so okay. We can also we already explained all the problem solving here. We are through with this. We already explained the problem solving here. Right now, my internet connection is not very good. As you can see, it is always what? Waiting to loading. We already explained this problem solving here. What else? Who is this? Daniela, please screenshot. Please screenshot the attendance so that I can see who are having their video on. So those with video off, they are absent. Okay? Then take the screenshot. Take the screenshot before we only have what, 25 minutes. What? 15. We only have 15 minutes.
Okay na po, sir.
Okay. So without their video on, absent. And send it to me. So there is no computation here. There is no computation. So we will do the live practice and problem solving every laboratory time until we can catch up to the current chapter. Okay? Until we catch up to the current chapter, we will proceed. That's why all of your practice scratch paper, you have to save your scratch paper because I will check it. I will check. I would want to know, I am interested to know who are doing practice and who are not. Please save your scratch paper. Later on, I will ask for it one by one. Okay, there is no other problem solving there. Maybe here we have problem solving here. So we still have 14 minutes. So here, this is the third. You can go back to our playlist. The playlists are all listed there in our channel. What is the name of playlist? The name of playlist is Numerical Methods, CE-A5, here. The videos are arranged, chronologically arranged. So you can always go back to the, okay, there is a computation here. Oh, we can practice. True error is equal to true value minus approximate value. So we can practice problem solving here. Okay. But that is very basic. Do we need to practice subtraction? True error is equal to true value minus approximate value. Do we need to practice the subtraction? Okay. Okay, we can do it if you want. Just also practicing that and also practicing calculator. So let us practice all of this. What is the problem? Additional problem. I recall I have additional problem to you when I explain this. Okay, I can recall. So we have here the given fx is equal to 7e 0.5x. Okay, so we only have 10 minutes. We only have 10 minutes. Let us practice here. Okay, using this as our practice. To find the true error, for example. Okay. So let us use our here. This is our practice. In share, I will share to you our whiteboard. So let us do what? Do the practice fx is equal to what? 7e raised to the exponent. What is the exponent? Exponent is 0.5x. Okay. So 0.5x. 0.5x. So this is our so and one of the question is find the approximate value of first derivative. Okay, using h 0.3. Okay. H is equal to 0.3. So find the first derivative. That is the first question. Oh, it's very easy. What is f prime x? Okay. Question mark. Okay. How to do it? Very easy. We have what? Formula is, what is the formula? Fx plus h minus fx divided by h. This is our approximation. This is our approximation of the first derivative. And what is our specific question? This is a general question. The specific question is at x is equal to 2. What is our value of that formula? X is equal to 2. That is in our video here. Okay. If we do that, we will find the correct one. Okay. So Let's do this. So what? We need f x plus h. Okay. We need to solve this. Okay. So how to solve this? This is the function. 7 times e to the what? To the exponent. That's our exponent. 0.5 times x plus h. What is x? X is 2. H is 3. So 2 point. So times 2.3. That is how you do it. Okay. 2.3. That is the so what is fx? Fx is equal to what? 7 times e raised to the exponent 0.5 times what? Times 2. Okay. By substituting h is equal to 2 and h is equal to 0.3. So if you do this in your calculator, okay, using calculator, what will happen? Let us use our calculator. So what? 7 e. Look at your e. E is what? Here.
Alpha.
Red.
Alpha.
So you have to press shift rather than alpha. If you press alpha, that is wrong. Press shift. And then press E. Okay? So you have to press that and raise to the exponent 0.5 times what? Times 2.3. Is that positive or negative? Our exponent. Is it positive or negative? Positive, no? Positive 0.5. Okay, so. Okay. So if you, that is 22.1. Okay, it is 22.1. Our whiteboard. Going to our whiteboard. 22. This is 22.1. Okay. So next. Next, the other one. So just go back to the formula and then instead of 2.3, use 2. So just click equal sign. That is 19.0. So 19.0, we have what? Here. 19.0. So therefore, we can now find out the value for this. For the f prime x at 2. So at 0.2. Okay. So we have what? The numerator is what? 22.1 minus this one, 19. 19. So divide by what? H is 0.3. So divide by 0.3. So if you do this in your calculator, you can find out that you have 2.1 minus 19. And then divide by 0.3. And therefore, your answer is
10.33.
Okay. 10.33. So 10.3 is enough. Okay. So 10.33. Very good. 10.3. 3333, no? So 10.3. Okay. So let us go to the answer. If we are correct, so 10.3. So our answer is correct, 10.3. Okay. This is 10.3. Okay. I will show it to you. I will show it to you here. Our answer is 10.3. And this is the same. Okay. 10.263. Okay. So that is our last practice for the day. We will continue. Let us find out if there are also there are other problem solving here. So let us continue. Please remind me next week, Daniela. Please remind me we are on the third lecture video, and at what? We are at 12 minutes 40 seconds of the video. We are at the 12 minutes 40 seconds of the video. So we will go back to 12 minutes 40 seconds of the third video inside the